Hi everyone, welcome to video 2 in our DP-700 exam preparation course. Today, we're going to be exploring workspace settings in Fabric, and specifically those ones that are important for data engineers, right? So we're going to be looking at Spark settings, we're going to be looking at domains, we're going to be looking at OneLake settings, including the OneLake File Explorer, we're going to be looking at shortcut caching and Apache Airflow job settings as well. So let's jump straight into it. Okay, so let's start off with Spark settings. So if you're a data engineer and you're working in Fabric and you're running a PySpark notebook, then you're going to be using the default starter pool, right? So say you're writing some code to load this dataset from ADLS Gen 2, clean it, load it into a Lakehouse table. Well, like I mentioned, we're going to be using this thing called the starter pool. So before we can look at customization of Spark, we need to really understand what the default is, which is the starter pool. And it's actually one of the big innovations with Fabric, right? So it's basically a Spark cluster with this configuration. All of the nodes are medium. It's got auto scale enabled between 1 and 10 nodes, but that does depend on which Fabric SKU you're using. If that's for F64. If you're using a lower SKU, you'll have a lower minimum maximum, or lower maximum at least. And you have the ability to dynamically allocate executors. Okay, so you get this cluster available to you. And one of the benefits of a starter pool is that it's available all the time, right? We have very quick startup speeds for Spark sessions, sometimes around 10 seconds normally. That's because Microsoft maintains these nodes and clusters that are available 24/7, kind of globally, right? Looks a bit like this. This is what starter pools are. Now, you might be thinking, do I need to pay 24/7 for this availability of always on Spark servers? No, it's actually billed when you start running code on them, right? So you start off small and it can scale up because the default settings are between 1 and 10 nodes. So it can handle pretty good jobs on its own. So let's just dig into some of those settings in a bit more detail. Because when we go on to customization of our Spark clusters, we need to know what these things are, okay? So the node that we talked about here is basically a commodity server. That's what Spark is, distributed computing. So instead of doing everything on one computer, you're spreading your load across many computers. So the node here we've got a maximum of 10. It's going to start off low, and then if it needs it, when it plans your job, your transformation, whatever you're doing, if it needs it, it's going to scale up. And on these nodes, we have executors, basically Java virtual machine processes that churn through whatever tasks that are given to them, right? So transforming data. And obviously it's working on partitions of data, right? So it's not the whole data set. One of the benefits of Spark and kind of like the core use case is really large data sets, right? So gigabytes, petabytes, terabytes, whatever it is, they can normally find a way to transform it. So when we look at this overall architecture, we've got two really leverage points for scaling if we need to, right? We've got obviously the auto scale of the nodes and the allocation of executors. Now, both of these contribute towards higher levels of parallelism, right? Splitting your data more and performing more processes in parallel to carry out the tasks that have been assigned to it more efficiently. So let's talk about some of the limits of this starter pool and when you might want to think about creating a new custom pool. Well, the first one, and probably the biggest one, is data size. So if you've got very, very large data sets, that starter pool might start to struggle, right? If all of your nodes are always being used on that particular job and your allocation of executors is always right at the top, you might want to think about creating a custom pool and using that for this particular job. The other thing to think about is around concurrency. So here I'm talking about multiple users all using the same starter pool in your organization. Obviously, it's a limited set of resources. So if you have multiple people or multiple jobs all executing at the same time, they're all going to be using that limited resource. The other one where you might want to think about a custom Spark cluster or custom Spark pool in Fabric or in any Spark environment really, is when you have high variance between job resource requirements. Okay, so you might have one really large job a day, but then you might have lots of little ones throughout the day. Now you might want to split those into two custom pools that are better suited to each of their individual needs. And the other one is around the type of work that's being done, right? So here in this exam, we're focusing on data engineering, but data scientists, if you're training ML models, you're likely to be wanting a custom pool as well. So instead of the starter pool, you choose that you want a custom Spark pool. So here is an example of a custom Spark pool. Here I've increased my Fabric SKU to F 128. I've increased the node size to large, and I've got the same range in the auto-scaling and in the executors. Now, one thing to be aware of is that when you make this change, when you use the custom Spark pool or any custom Spark pool, you're going to see your Spark session times go back to what you might normally expect from Spark session time startups. So a few minutes, really. It's a similar effect to if you've used managed private endpoints in your tenant, you also get the same effect. They can't use that starter pool in your Fabric tenant after you turn on managed private endpoints. It's a very similar, albeit for different reasons, it's the same effect. Okay, so where can you create and manage custom Spark pools? Well, there's a few different options available to us as data engineers in Fabric, right? Now, number one is in the Workspace settings. So we'll have a look at this in a minute, but you've got a tab here called Pool, right? And it will show you the default, which is a starter pool. But then if you click on this button here, then you can actually create a new pool, right? You can define your node size you want, if you want auto scaling, if you want to dynamically allocate executors, and the ranges for both of those as well. And by default, if you set this up, all of the notebooks and the Spark jobs that happen in your workspace are going to be using those settings. Okay. Now there is another setting, customize compute configurations for items, which means that you're going to allow or disallow individual users to change their Spark settings for individual jobs and notebooks, right? Obviously the mutable settings in Spark. So option 2 is, well, in the workspace settings, you'll find this second tab, right, called environment. Now the environment is a way to store and manage Spark settings, but also Python libraries and other things as well. So an environment is a special Fabric item where we can define things like Spark settings, Spark properties, and we can also pre-install things like Python libraries from the Python package index, for example, and then we can use that in multiple places within our workspace, right? The first one is using it as the default environment in your workspace settings, and it's going to have a similar effect, right? If you choose this, what it's going to mean is that any notebooks and Spark jobs that you create or run within your workspace, it's going to use that environment or the settings that you define within that environment. This is what this looks like when you're defining an environment pool. Now, the benefit of this is that it allows Git integration, right? With the previous example, setting it, like hard coding it in the workspace settings, you can't actually check those settings into Git. So if that's something you want to do, which you should be doing, then it makes it possible with an environment. One of the downsides to be aware of the environment, and there are a few, is that you can't use them across workspace, right? So you can't have your environment in like a central workspace and then reference it across lots of different workspaces. You'll have to duplicate it through probably version control or deployment. So that's option 2. The third option for managing Spark settings, and there's more than this, but I'm just picking 3 of the main ones, is to use an environment again, but just to use it as an item in the workspace, to not set it as the default in the workspace, right? And in this way, we can have job level configuration of Spark. So you might have this notebook to use this environment. You might create another environment. This is what I mean by, different jobs can have different environments attached to them. So theoretically, you could have 4 or 5 different environments in your workspace for covering 10 different jobs, for example, that you run on a regular basis. Again, it's a good thing because you get an optimal configuration for each job that you're running in the workspace. And you can check your environment into version control, but you have these cross workspace limitations. Hey everyone, so I've just switched over to Fabric and I'm going to show you some of those features that we just talked about. So I'm in a workspace here. I've created DP-700 workspace. Got a few items in there, but for now, we're going to focus on the workspace settings up here, right? So we can open these up and we'll talk through some of the things that we've just mentioned there. And I want to start with the Spark settings, right? So under data engineering and science, we can click on Spark settings. Now this is the view that I showed you in the slide, right? So you can create, by default, it's using the starter pool, but we can come in here and we can create a new pool, right? If we want to customize the Spark pool. From there, it's very simple. We give our pool a name, dev. We can't change the node family. It's always memory optimized, but we can change the node size, right? And this is going to vary depending on the SKU you have, the capacity that you have. What's also going to vary by the capacity, because obviously the capacity gives you a limited set of resources, like the size that you can scale your Spark cluster up to is highly dependent. It's kind of like you can calculate it mathematically. Depending on what SKU you have is the maximum number of nodes you can have as well. So that is basically all there is to creating a custom pool. I did mention the other method. So option 2 that we discussed was creating an environment, right, and using that as your default Spark configuration within the workspace. So to do that, you just need to click this button on. Now, if you've got an environment already in your workspace, in this one I don't, so I can create a new environment like this very easily, and I can call it pool dev end. And then from there, it's going to allow me to configure Spark, but it's kind of going to package it up in a kind of more portable way. So yes, we can do installation of Python libraries. We're not going to be discussing that in this video. We've got the Spark settings here within an environment. Now this is the new native execution engine that you can turn on for your workspace, or for the environment more accurately, but we're using this environment for this workspace. Here is where we can define our Spark settings. We can also, in an environment, add individual Spark properties, right? So this is one of the only places that you can do that. Obviously you can do it within the code as well, but at a settings level, you can also change individual Spark properties. Okay, so let's say I'm happy with that environment. If I go back to my workspace settings here, I go back to my environment, turn this on. Now I have this available environment. I can turn this on like this. So what that's going to mean is that when a user creates a notebook now, it's going to use this pool dev env as the Spark environment. So other than customizing Spark pool, there are some other Spark workspace settings that we can manage. Now the first one is this reserve maximum cores for active Spark jobs. And to understand what this is, we need to understand how this works really. So when a user executes code in a notebook or job, the default is to do an optimistic planning, right? To basically say what's the minimum amount of resource that's required to perform that task, and they're going to reserve that minimum, right? So going back to our example here, if we've got a 10 maximum node cluster, well, the minimum when we plan the job is going to be 3. So it's going to reserve 3 nodes in our architecture, leaving the others available for use by other jobs or other people. So it's flexible, but sometimes when we go to scale, we don't really know, well, we do know what the maximum is, but it doesn't reserve the maximum. On the other hand, when you tick this box, it's going to do kind of pessimistic planning. It's going to look at what is the maximum amount of resource that I need to complete this job. And right at the beginning, it's going to reserve that maximum amount, which helps with stability, right? Because you're not going to come up against failure to scale when it needs it. It's reserving it outright right at the beginning, but it might impact other jobs, right? Because they've locked these nodes now just for use by this job, even if they're not being used actively all the way through the execution of that job. So it's good for this job, but it's bad for other jobs. We've also got the high concurrency tab. Concurrency in this context, we're referring to the single user using the same Spark session with multiple notebooks, right? So you can allow users in your workspace to do this. The second option down here is to do the same, but for pipeline runs, right? When you're triggering a notebook, normally in a for each loop where you've got some sort of parallelization, maybe you've got a repetitive running through lots and lots of notebooks in one for each loop. This setting is going to allow you to use the same Spark session for that iteration, right? And it does that with this concept called a tag. Looks like this. So it requires some configuration in the pipeline itself. And you say, okay, I want all of these notebooks to use this particular session tag. And then when your pipeline runs, it knows, okay, this notebook needs to run on this session tag. And actually it's going to iterate through 10 times and they've all got the same session tag. So it's going to do it concurrently. Now, although the focus for DP-700 is around workspace level Spark settings, I think it's important just to mention that, your workspace, you might have multiple workspaces and they exist on a capacity, right? And there are some Spark settings at the capacity level, so in capacity settings. And it's mainly for blocking or controlling what gets done in that capacity. So a capacity level admin can allow workspace admins to create custom Spark pools or disallow, and they can also disable the use of starter pools or enable. And the reason I bring this up is that if you're a data engineer working in a workspace, you might not be a capacity level admin, but you might have these settings like grayed out for you, right? You won't be able to create custom Spark pools. You might be wondering why that is. So I thought it's important just to mention that. Okay, next up, we're going to talk about domains. So a domain, according to Microsoft, is a way of logically grouping together all of the data in an organization that's relevant to a particular area or field, right? So what we mean by this normally is it's a grouping of workspaces, right? And it normally aligns to your business organizational structure, right? So most businesses have an org chart. It might not look like this, but it might be region-based, it might be marketing, sales, IT, that kind of thing. And so what you're going to be doing with domains is mapping your business org chart into some sort of domain design, right, in Fabric. Now, this is just an example. It doesn't have to look exactly like this, and there's many different permutations and designs. I'm just showing you how it could look. Then once you've got your design, you can then assign your workspaces to individual domains and subdomains that you create in Fabric. And one of the reasons why you might want to do this is around data discoverability, right? Currently, this is one of the benefits of domains. And within the OneLake catalog, you can see this search option, right? So you can search for data and information and items related to each individual domain. Now, currently, what can you do with domains? Okay, so it's a little bit limited, but here are the things that is possible to do through a domain. Now, it's divided up in 3 different roles. Now, you won't find this in the documentation. This is something I've created just to lay out how I think is best what's possible with domains. But we talk about Fabric admins, and domain contributors. And each of these has different roles or capabilities available to them. So the Fabric admin is your tenant level admin. They have the ability to create and delete domains because this happens in the tenant level settings. They can also appoint domain admins, these people. And they can also view all of the domains. Now, a domain admin can only view the domains that they're the domain admin for. Right, they can't see the whole bigger picture. They can also appoint these domain contributors, domain admins. Now, a domain contributor, we'll get to in a second, but it's basically a workspace admin. And the only thing that they can really do is assign their workspace to a domain within the workspace settings. So if you're a Fabric admin or a domain admin, you can assign workspaces to domains on a more bulk level. We can assign it by workspace name, by workspace admin, or by capacity, right? So this is like bulk assignment, or at least these 2 are. So that can be done by the Fabric admin or the domain admin. Now, the last one I want to just point out here is around delegated tenant settings. So there are some settings that are traditionally set at the tenant level, but if it's enabled by the Fabric admin, they can be delegated down to the domain level. So they can be set uniquely for that particular domain. Now, the 2 currently available are around sensitivity labeling, so having a default sensitivity label for your domain, and also certification of items as well. So like endorsement, basically. Okay, so next up, I wanted to talk about the OneLake File Explorer and OneLake more generally. Okay, so you might have seen an image a bit like this, right? Around Fabric, around the different engines in Fabric and the different experiences, although I'm not sure if they're still called experiences now, but what used to be called experiences. And you get this picture where all of the data that you're creating, whether that be via the Spark endpoint in a lakehouse or t-sql endpoint in a data warehouse, for example, all of that lovely data ends up in OneLake. And all of the data that exists in OneLake, you can view using this tool called the OneLake File Explorer. Now, it's useful because it helps business users, this is just one of the use cases, business users can download or install the OneLake File Explorer, essentially like OneDrive, right? You get it on your local machine and you can see all the files and folders for what's in OneLake, so all of the Delta tables. If you download and install this File Explorer and you've got KQL databases and Power BI, you might think that by default you should expect to see those in the OneLake File Explorer, but it actually doesn't work like that. Okay. Now, there is a tenant level setting to allow users to use OneLake File Explorer. So if you want to turn that on or off as a tenant admin, you can enable or disable that. So the point I wanted to make was this, right? By default, only Spark stuff and data warehouse stuff, by that stuff I mean Delta tables, get written into OneLake and therefore into the OneLake File Explorer as well. So if you've got KQL databases and Power BI semantic models, by default, they don't get written into OneLake. But there are settings to enable that. With KQL databases, you should see this in the UI, right? OneLake availability on or off. It's a very simple button, looks like this. Now, the key point to remember is that there's probably data streaming into this database and you have different tables. But when you turn on OneLake integration for a KQL database, it's only going to work for new tables, right? So you should do this at the beginning when you start building your KQL database, if you want this functionality. It's not going to backfill any existing data that you might have in that KQL database when you turn this setting on. So that's very important to understand. Similarly, for the Power BI semantic models, okay? Now for this one, there's a tenant level setting that we need to enable to allow us to do this. And then once you've turned that on, for each individual semantic model, you're going to want to go in there and turn this OneLake integration on. Now, one of the benefits of this is that the data now is truly actually in OneLake, right? Before it's not. So that means that it can be used in different experiences, right? The true kind of vision for Fabric. So you can use shortcuts. You can shortcut a table in a semantic model, for example, into some lakehouse. Use all of these different experiences in a much more integrated way. Okay, so just switch back to Fabric, and I want to give you a little demo about the OneLake File Explorer, how it works, and how we can enable it for semantic models and also KQL databases as well. So in here, in my workspace, a little bit messy, but I've got a few different items in this workspace. I've got a warehouse, an event house, a lake house, and down here a bit, I've got a semantic model, right? So it mimics the slide that you saw there. So what I'm going to do is I'm going to switch over to the OneLake File Explorer and have a look at this workspace through that. So if I open up my File Explorer here, I've already installed it. So here it is, OneLake Microsoft Preview. So it is a preview feature, bear that in mind. And what you can see here, when you load it up, is a long list of every workspace that I have access to in Fabric. Right? So we can scroll down and we can find the one for DP-700. So this is the workspace that we're interested in. And just to sync it, just to make sure that we've got the latest and greatest in there, we can right click on the OneLake tab here. Okay, so we've got the data warehouse, CustoDB, a lakehouse, and some other stuff like data flow and some staging. We don't really care about that for this tutorial. Let's just inspect what we get. Now, all of these tables or all of these data stores, they have data in them, right? So I have created at least one table in each of them. So for the lakehouse, it looks a bit like this. So I've got this table, agent details, and this is my delta table in that lakehouse. So that has worked correctly, right? We've got data in OneLake, as you would expect in a lakehouse. If we go back to the data warehouse now, again, we've got tables, DBO, agents. Again, we can see that delta table for the data warehouse, which is what you'd expect. Now, the custo database tables is empty, right? So we don't have anything in there currently. We don't have a semantic model in there. So let's change some of the settings that we need to see if we can get that data in our OneLake and in our OneLake File Explorer. Okay, so the first thing I'm going to do is I'm going to navigate to my KQL database, which was here. And this one's quite simple, right? So when it loads up, you're going to see, or it's actually also on here. So it's on the toolbar at the top, but the main one is here. OneLake on the sidebar, you'll see that currently the availability is off. Crucial point, when active, new tables in this database are available. So not existing tables. So either you're going to have to recreate your existing tables. Oh, there is actually a setting now. Apply to existing table. So I believe this is a new setting, like in the last few days. Apply to existing tables. All I would say is if you get a question on this in the exam, I would assume that that doesn't exist. So for a KQL database, for OneLake integration, it doesn't apply to existing tables, would be my answer if I was to get that in an exam, because this is, I believe, a brand new feature. Let's try it. Turn on. Okay, so we've got one table available. So let's go and have a look. Okay, so I'm back in my File Explorer, and if I just sync it again, sync from OneLake, I can see the data's been modified there. Custo, tables. Okay, so I think what is happening now, so this is a brand new feature because I tested this 2 days ago and this wasn't available, but now you get that pop-up to say, okay, for existing tables. And so it's going to create the structure of your KQL database, but it's only going to be for new data. So if you've got data streaming into it, say I was to create an event stream that ingested data into this game events table that I've got set up, then it would then be populated in the OneLake File Explorer. But note that it doesn't backfill all of your existing data. Now I do actually have data in here. So if we just do a quick query of this, there is data in this table, but it doesn't get backfilled into OneLake File Explorer. Okay, let's have a look at the semantic model next. So if I scroll down to my semantic model. It's this one right at the bottom. I'm going to open up the settings here. And I've already set the tenant level admin settings that was step 1 for this one. And I want to scroll down to OneLake integration, this one here. It's going to automatically write data from your semantic model to Delta tables in OneLake. Okay. So if I turn this on, apply, make sure your semantic model includes one or more tables. So let's go back to OneLake. If I just resync again, we'll just go back up to DP-700. Okay, so I've just resynced the OneLake file explorer, and you can see that we still don't have the semantic model, right? And the reason for that is this. It needs to be an import mode model, right? So the model that I've got in my workspace is direct lake. So it needs to have at least one import table in your model for it to get written into the OneLake file explorer. So just bear that in mind. The next thing I want to talk about is shortcut caching and shortcuts more generally. Okay, so hopefully you're familiar with shortcuts, what they are by now, but basically shortcuts allow you to access, and here we're talking about external shortcuts. So accessing external data that's in things like AWS, S3, buckets, or Google Cloud Storage, or Amazon S3 compatible locations, right? So things like Cloudflare, basically things that use S3 in the back end. We can access those files in Fabric without the need for traditional ETL, right? Just sends a kind of a reference to that location. And then when it's needed in Fabric, i.e. when you're querying it, then it's going to, by default, do it on the fly every time you need it. Now, the problem with that is that a lot of these cloud providers, Google, AWS, they charge for egress, right? So they don't like it when you take data out. Now, with shortcuts, what Microsoft have introduced is this feature called shortcut caching, right? And it's designed to reduce the costs of egress, right? By storing kind of like a cache or a copy of the data within the Azure cloud, right? Now, this can be enabled for a workspace, right? So all of the shortcuts that are created within that workspace to external platforms are going to be using this caching. So this is what this might look like. You're in your Fabric tenant, which is of course in the wider Azure cloud. And you've got a set of lakehouses here, and you've set up a number of shortcuts from AWS S3, Google Cloud Storage, AWS Gen 2 as well, which is kind of inside the cloud. It's not an external provider. So the first thing to note is that it's only available, this caching thing, or it's only really necessary for AWS, Amazon S3, Google Cloud Storage, and shortcuts to Amazon S3 compatible locations. There's some other key rules with shortcut caching to be aware of, right? The first one is the 24-hour rule. So if you don't access the cache, so if you've got a cache here and you don't access it through a query or through a data pipeline, ingesting that data or whatever is happening downstream, if nobody touches that cache for 24 hours, it gets removed. That means that the next time you query it, it's going to go back to source. There's also a 1 gigabyte maximum, right? So individual files that are greater than 1 gigabyte will not get cached, right? So if you're bringing in 10 gigabyte files from Amazon S3, it's always going to go back to source. It's never going to be cached, even if you've got that setting turned on. Okay, let's very quickly finish off this video with a little bit of talk about Apache Airflow jobs. Now, I think they've recently changed the name of these as well. It used to be called data workflows. That was a little bit confusing. So I think they've gone back to naming it exactly what it is. And it's basically a managed service around Apache Airflow jobs. And although Apache Airflow jobs individually are not really assessed within the DP-700, or at least I wasn't, and it's not in the study guide, but the settings behind them are. So you need to understand a little bit about how they can be customized. Now, to run an Airflow job on any platform, you need normally some sort of server to run the job on. And what Microsoft are providing is basically a pool that can allow you to run these jobs. So for those of you that don't know, Apache Airflow is basically an orchestration tool used a lot in data engineering. It allows you to write DAGs, directed acyclic graphs, normally using Python, and you normally have to run them on a server, right? Or through a provider like Astronomer, for example. Where in Fabric, what Microsoft have provided is a mechanism to create and run Apache Airflow DAGs all within Fabric, right? So you don't need to manage any of that. They manage all that for you. You can configure a few things though about the server, the cluster that the jobs run on. This is slightly separate to Spark servers, similar terminology, but different. So you can create pools again, but you can define a few different settings here. So the compute node size, you can enable auto scaling, different number of nodes to run Apache Airflow on. As I mentioned, is for orchestration, and we'll look in more detail about orchestration across the Fabric platform using notebooks and data pipelines, but that's in a future video. So that is the end of this video. I hope you enjoyed that one. Just a quick reminder, if you want to join us in our DP-700 bootcamp, we have live calls every week between now and the end of March. If you're joining after that date, obviously you can watch all the recordings. We also have up to 60 hands-on tutorials to help you with getting hands-on with Fabric, particularly related to data engineering and DP-700 tasks, right? So if you want to get hands-on, recommend you join that. If not, I'll see you in the next video in this series.